The semiconductor era stands at the core of national growth. Innovation in technical education continues. IEG leads domestic and global technical education for future technology talent. IEG Corporation. IEG provides a wide range of engineering and science training programs required in industrial fields, offering education solutions that integrate specialized hands-on equipment with emerging technologies. As Korea's #1 tech edu company, IEG develops customized technical training programs and operates technology education businesses incorporating new technologies. Hands-on and experience-based semiconductor education solutions. IEG's semiconductor training equipment is designed to help students easily understand, assemble, and disassemble complex semiconductor processes. Learners can directly observe and interact with each process to acquire semiconductor technology. IEG's 8 semiconductor processes are specialized training systems based on representative semiconductor manufacturing processes, providing systematic education in semiconductor equipment theory. Wafer preparation. This process cuts and polishes a silicon single crystal ingot to prepare the substrate for circuit fabrication. Surface defects and wafer flatness are controlled at this stage. Oxidation. A silicon oxide layer is formed on the wafer surface to create insulation and protective layers. The oxide film is grown using high-temperature oxygen and steam and is used as an etching mask or transistor gate oxide. Photolithography. Light transfers mask patterns onto the wafer to form the fundamental circuit patterns. The pattern photoresist protects required areas during etching. Etching. Using the lithography pattern as a mask, unnecessary material layers are removed by chemical or physical methods. This process engraves fine circuit structures onto the wafer, with high-precision dry etching commonly applied. Thin film deposition and growth. Thin layers of metals and insulating films required for circuit operation are deposited onto the wafer. These films perform critical functions in transistor gates and interconnections. Ion implantation. Dopant ions are accelerated and implanted into the wafer to modify the electrical properties of silicon. Specific regions are formed as P-type or N-type semiconductors with precise control of ion type, energy, and concentration determining device performance. Metallization. Metal interconnections are formed to connect devices to each other into external circuits. Highly conductive copper or aluminum is deposited and etched to create current pathways. Multiple wiring layers can be built depending on chip complexity. EDS and packaging. Electrical die sorting applies electrical signals to finished chips to test performance and identify defective dies. Packaging is the final step that protects selected chips and prepares them for mounting onto substrates. IEG Semiconductor Education Solutions with VR and AR. IEG's VR and AR training solutions allow learners to operate and experience semiconductor equipment in virtual environments, enhancing immersion and comprehension. Learners can enjoyably acquire complex STEM knowledge through various missions in virtual environments. IEG's VR systems integrate professional equipment with new technologies to deliver technical education solutions for the future era. Many domestic and international institutions have selected IEG as their core technology education partner. Through IEG's specialized training equipment, experts across various STEM fields are trained every year. IEG's education solutions align with national semiconductor talent development initiatives and provide one-stop construction of practical technical training environments for schools, institutions, and major enterprises worldwide. A company leading semiconductor technical education and setting new standards. IEG will continue advancing educational innovation for future generations. IEG Corporation